Probability, example 15. So this is going to be a rather long video. Our example 15 is going to help us understand how to use this particular table. So on the next couple of pages, we have a wonderful application using probability that I think you might enjoy, you might find interesting. So let's go ahead and get started. A home pregnancy test was given to women. Then the pregnancy was verified through blood tests. The following table shows the results of these tests. Find the probability that the person was not pregnant given they had a positive test result. Please recall that this would be considered a conditional probability. So remember that changes the number of outcomes. So positive test result. What was our total for a positive test result? 91. Of those 91, how many people were not pregnant? Okay, so that's 4. Okay, we'll go ahead and leave this as a fraction for now. In our application, we will use percentages for our final answers. B, find the probability that there was a positive test result given they were not pregnant. So again, this is a conditional probability that will change the number of outcomes. So the total that were not pregnant was 25. How many of them had positive test results? 4. So the scenario described in example 15b is called a false positive. Think about it. They were not pregnant, okay, but they had a positive test result. So it was positive, but it was wrong because they were actually not pregnant. So we'll talk about false positives and false negatives a little bit later on. Medical tests and false positives and false negatives. So we're going to put some of our reasoning skills to the test. So suppose a certain disease has an incidence rate of 0.5%. That means that the disease afflicts 0.5% of the population. A test has been devised to detect the disease. The test does not produce false negatives. That is, anyone who has the disease will test positive for it. But the false positive rate is 7%. In other words, 7% of the people who take the test will test positive, even though they don't have the disease. Suppose a randomly selected person takes a test and tests positive. What is the probability this person actually has the disease? All right, a little intimidating, right? Well, they have found that medical students who use the very complicated formula for this, that 18% of them actually got it right. So once they started teaching this to them in a more logical fashion, they found that the success rate actually greatly improved. So let's go ahead and use some logic to actually solve this problem. I'm going to break it down a bit. Right, suppose a certain disease has an incidence rate of 0.5%. So how would we write that as a decimal? Hopefully you recall that we can do that by just moving the decimal point 2 places to the left. So that's the probability of having the disease in general. All right, the other thing that was said is that this test does not produce false negatives. That is, anyone who has the disease will test positive for it. So that is a certain event. All right, so that means that not only will anyone with the disease test positive, but anyone who tests negative does not have the disease. So the probability that they will test positive given they have a disease, that's for certain. So we'll put a 1 there. All right, the false positive rate is 7%. In other words, 7% of the people who take the test will test positive even though they don't have the disease. So what's the probability that they will test positive given they don't have the disease? Well, they just told us it was 7%. And so that written as a decimal is 7/100. Okay, so for these problems, we create a hypothetical situation, and so we select 10,000 people, and really the purpose for that is to make our numbers nicer. So 10,000 people at random and administer the test for the disease. So how many do we expect to have the disease? So we need to look back at that incidence rate. Probability of having the disease was that 5/1000. So to determine the 5/1000 of 10,000, remember of means multiply in most cases. So when I multiply the 5/1000 times 10,000, I get 50. Okay, what am I going to do with this number? Okay, that 50 goes down here for the total of people who have the disease. This means the other, how many people do not have the disease? Well, you'll look at, remember our 10,000 total. If 50 have the disease, then 10,000 minus 50 gives us 9,950 people. 9,950 people do not have the disease. Okay? Of those who do not have the disease, we said 7% will test positive. Okay? So that means about how many people who do not have the disease will be expected to test positive for the disease. So they said of the people who do not have the disease, this is how many people who do not have the disease. 7% will test positive. So to find that is 0.07 times that 9,950, and we are going to get 696 and 5/10. Okay, where does that go? Of the people who did not have the disease, this many people test positive. So it's going to go in this box right here, this part of the grid. All right, so from this point, it won't be too hard to figure out what should go in this box right here, because the total of all the people who do not have the disease should be 9,950, right? So we're just going to take our 9,950 and subtract our 696 and 5/10. And I will get, I'm going to write this in another color because I think it might end up being a little bit messy here. 9,253 and 5/10. So it might be a little hard to believe, but we can fill in the rest of this box, okay? So one of the first things that they said after the incidence rate, that if the person has the disease, the test does not produce any false negatives, I should say. So if it doesn't produce any false negatives, that means that if they have the disease, they will not test negative. So that means that for certain, if you have the disease, you'll test positive. All right, well, most of us know how to add. So to get the total of the people who tested positive, we are going to add the 50 plus the 696 and 5/10. So that's going to give us 746 and 5/10. And then the next row, 0 plus the 9,253 and 5/10. Hopefully you're not grabbing for your calculator on this one. So it is a good idea for us to add the total that we came up with here, just to make sure that that gives us 10,000. So I pause this to give you a chance to do that. Okay, hopefully you're satisfied with your results there. Sorry, I went the wrong way. Okay, so you have reference to the chart at the bottom of page 10, so I'm going to ask that you look at that as we finish up here. It says, now how many people test positive for the disease? So we had said that that was 746 and 5/10, and we got that from the 50 who actually had the disease, along with the 696 and 5/10 who tested positive and didn't have the disease. So here is what they asked. what is the probability that someone has the disease given they tested positive? So our number of outcomes is not 10,000, it's the number of people who tested positive. And of all those people who tested positive, how many people had the disease? 50. So generally we change these to percents. So remember, anytime you need to change a fraction or a decimal to a percent, we multiply by 100%. And that gives us 6.7%. This means that of all of the positive tests, only 6.7% have the disease. On the flip side, all the people that tested positive, let's go for the number 696.5, or more importantly, it's nice to look at the percentage. 100% minus 6.7% gives me 93.3% of them do not have the disease. So that is why when you go to the doctor and they give you an initial test, they always do follow-up tests, because sometimes they will have less expensive tests that are not exactly reliable, so they have to follow up on that.